Hello, everyone. So today we are looking at exponential functions. Okay, that's the last class of grade 10. Okay, so we're going to know how the shape look like, and also the effects of A, the effects of Q, how also B affect the shape, and also finding the equation of exponential function. Okay, so let's just dig in and see. You know how I like to start my class with? I like to start with the questions so that you can try. If you don't understand, then this class is for you. But again, you must come back and do the questions. Okay. So I want you guys to know here, just a hint here. You're supposed to actually divide by 3 both sides. Then you can have your Q. Then also you must take the 3 inside the bracket. Then you can also have your Q. Okay. So that's a hint on that one. Now let's move on to our today's class. Now we need to understand the shape first of an exponential graph. So exponential graph, we have got one asymptote, and that asymptote is the x-axis. Okay, so it only have one asymptote when you're talking of the mother graph. Okay, so let's look at it and see. It's in the form of y equal to, so in the form of y is equal to b to the power x. Okay, so in this form here, what we will see is that if we are to look for y, the y-intercept, y-intercept is when x is equal to 0. So whatever value of b is, we know that it's gonna be 1, because we know that anything to the power of 0 is 1. So it means that here anything, let's say if I say a, or let's just put another value there, let's say maybe p to the power of 0 should be equals to a 1. Okay, so now what your graph looks like now is that it's gonna look like this. So let me just put it in. Yes. So it's curved, and you can see what is happening here. It's only approaching the x-axis, but not what is it? It's approaching the x-axis, but touching the y-axis at 1. Okay, so it's touching the y-axis at 1 because of what is it? When x is equal to 0, y will always be 1. So it's always cut at 1. So that's how it looks like there. So we've got the x and the y. Now, I want to know how A affect this whole thing, how A affect this. No, so if A is above 0, what we'll see is a normal graph like that. But if it's below 0, meaning to say A is negative, that will be a reflection. So for example, here, if we are to have, let's say this graph is y is equals to 2 to the power of x. Let's just say 2, and maybe let's say 2 to the power of x. In that case, our 2 is positive. So if it's positive, it means that our graph will look like that. Okay, now what about if it's negative? If it's a negative, now what we'll see, it will be reflection along the y-axis, along the x-axis, sorry, along the x-axis, and this is what we have. And what we have here, this will again will be -1, and in that case now we are saying this can be y is equals to -2 in bracket 2 to the power of x. Now that's how it looks like here. So it's 2 times, here is times. Okay, so that's what it means here. What about if we are to change the value of b? So this is the form of y is equals to a b x, but we are saying in this case here a is greater than 0, and here again here a in this case here is less than 0. So y is equals to a b x, but a here is less than 0. What about if we talk of b now? What will happen now? B can either be above 1 or 0, 1. So in this case here, it will be a fraction. B can never will never be equal to what called 1 or 0, sorry, can never be negative. Here can never be negative. This one can never be, can never happen. Okay, it can never be negative. That's what you need to remember. So it can only be a fraction. So if it's a fraction now, what you will see, it will be a reflection in the y-axis. So in this case here, this is y equal to a b x, but in this case here, our b is less than 0, 0, like that. It's between, it's a fraction, but here we are saying b is greater than 1. It's greater than 1, meaning to say it's a big number there. What about the same applies? We'll also see if it comes to its reflection. Its reflection will also be there. So we have something like this. Yeah. Okay. So that's our graph there, which is going to be y equal to a bx. But in this case, we are saying b is between 0 and 1. Okay, so that's what happens. So whenever you see, if it's a fraction, that's what we have. So let's just put it here and see maybe if we can use actual values. Okay, let's just draw a graph of y is equals to, maybe let's say 3, 3 to the, or maybe let's say 4 to the power of x. Okay, or let's say have another one, which is y is equals to, maybe let's say 3 again, but in this case now we say 1 over 4 in the power of x, like that. So let's try to draw them and see what we are talking about here. So if we are to have these two graphs, they are all both positives. A is positive, so we expect to see them, to find them on top here. So if they are positive, you find them on top there. And let's see what we have. We have a positive one, which is it's gonna go like that. Then the one with the fraction there is gonna be like this. That's what is happening here. Okay, so this one here is y is equals to 3, 4, x. Okay, and this one is y is equals to 3 in bracket 1 over 4 x, like that. Okay, so if it's a fraction, it's a reflection along the y-axis. It's a reflection along the reflection along the y-axis. If it's what is it? If it's a is negative, it's a reflection along what call the x-axis. Okay, so that's what we just need to remember when in terms of a and b. What about if in terms of what is it, q now? What happened to the what does q do? Q, like always, it's a vertical shift. Q is a vertical shift, so it means that it's either you're going up or you are going down. Okay, so it's a vertical shift. That's what you need to remember, guys. Q, you have been a vertical shift from the linear functions, quadratic functions, what you call hyperbolic functions, now on exponential functions. We are just doing the shift. Okay, so in this case now, remember in this, on the previous slide, asymptote here, asymptote is y is equal to 0. So our asymptote is y is equal to 0, meaning to say you are talking of the x-axis. That's the asymptote. But when it comes to now, when we have got a q now, our asymptote will change now. Let's say, for example, we're drawing a graph of y is equals to maybe let's say 2 in a bracket 3, not a bracket, sorry, 3x, and maybe let's say plus 4. Let's say have another one here, y is equals to maybe let's say negative 2 3x. Okay, let's say minus 4. Okay, minus 4, like that. Now let's see what will happen now when it comes to our graphs. Now when you have to draw the graphs, now you now know that in this case it's gonna be on top, That's what we see. But now we see that there's a shift here, vertical shift of 4. So we are shifting the graph 4 units up. So our new line here, our new x-axis will actually be equal to 4. So that's what we have here. That's our new axis here. That's our new 0. Now it means that if we are to shift 1 unit up, if it's gonna be at 5. So it's gonna cut at 5. It's no longer cutting at 1. It's now cutting at 1 unit above 4, which is 5. So now what we'll expect our graph to be, it's gonna be like this. That's how our graph will look like. Our graph will look like this, and that shows us, okay, the graph is going up, and we have got our y in our new x in our new asymptote now. So when it comes to asymptote now, asymptote in this case here is y equal to 4. It's no longer y equal to 0. So our asymptote, this q here, we know that it's our asymptote. Always just know that when you see any value there, that's our asymptote, which is y is equals to q. That's what you just need to remember, guys. Don't forget that. Don't forget that. Don't forget that. I'm just going to circulate it. Okay, let's have a look on this one here, where we are having another graph of maybe let's just put it a bit on top there. Now what we see is that this is our x, this is our y, and because of the negative, it means that it's facing where is it facing? It's facing down. So it's facing down, it's down here. So it means that our original graph should be on the -1, where it's just supposed to be what is it, where it's just supposed to be like this. So here it's a -1. Then if we are to shift it 4 units up, down, we know that our new asymptote now is -4. So we have something like this. That's our -4 there. And now it means that it's going to touch at -5. So at -5, what will we expect? We'll expect a graph like this. Those are just arrows, okay? Nothing to worry about. That's why -2, 3x minus 4. So the negative, it shows us the shape that it's supposed to be down below the x-axis, and that's the graph here where we have y is equals to negative what call 8 to the power of x. That's what we have there. That's why it's facing down like that, and it's also what you call below the x-axis. Okay. Then now when you shift that graph, we're just shifting it by 4 units. So it means that 4 units down, our new asymptote now will be equal to y equal to -4. So that's our asymptote in this case. Asymptote y is equals to -4. That's what you need to remember there. Okay, so always when you have this, that's that's your asymptote. Now let's move on to something again, which we call the domain, range, increase, decrease, and everything. So here we know that when you're talking of domain is your x values occupied by the graph, and this is your y values. And now this for the increase, we know that is positive gradient. And here is negative gradient. Let's master that. When we have an increase, it's a positive gradient, decrease is a negative gradient. Okay, now let's see what we'll do now. Let's say if we are to have a mother graph, let's just say a graph without what is it, the x. Let's say this one here without the q, sorry. So let's say this graph of, maybe let's say graph of y is equals to let me just see here. Touching at 1, And that's our graph there. Let's say this is y is equals to what you call 3 2 to the power of x. That's what we have there. Okay, so remember the 3 is not, it's the 3, the value there does not, you don't need to worry about it, because just the stretch, that's all. It's just the stretch. And in this case, we are more worried about the shape of the graph. So whenever it becomes negative, that's where you need to worry now. But otherwise, the magnitude of that a does not matter, since you'll be drawing what called one graph at a time. Now, here is y is equals to that. So when I look at the domain here, domain in this case here, it's not restricted. So domain is from negative infinity. So x element of negative infinity to positive infinity. Or you can just say x element of real numbers. X element of real numbers. Okay, that's all. Then what about the range? Let's talk of the range now. Range, because we're saying here occupies all the x values are occupied by this graph. But in terms of the range now, range becomes a problem now, because we are saying it's gonna be only on top here. It's above. So it's above 0. So it's y greater than 0, because it will never touch down there. So it's y greater than 0. So in this case here, what it means, if we've got a q, it's gonna be just y greater than q. That's all. And you can't say or equal to, because it's an y equal to 0, it's an asymptote, it does not touch it. Okay, now let's see if we are now to introduce q now. In this case here, let's introduce q and c. So here it's have what is it? Let's say we are shifting our graph. Let's say we shift our graph by 2 units up. So here is 2. So it means that our graph will be at 3 there. So let's just draw our normal graph there going up. Okay, and that graph is y is equals to, maybe let's say what you call 3 to the power x, what you call plus 3. Now we are now having a plus 2, sorry, plus 2. Okay, now it means that we are now having a new asymptote now, which is this which is 2. So in this case here, the domain remains the same, does not change, x element of negative infinity to positive infinity. Or you can say x element of real numbers. Okay, so it's oral. Then here, what about the range? Let's talk of the range. Range, you're going to find your y values only above 2. Only above 2. So it's going to be y greater than what you call y greater than what you call 2. So in this case here, when you're dealing with that, it just means that it's y greater than a q, like that. Okay, that's what it means. That's what it means when in terms of the range. Okay, so always remember that. Don't forget that. Now, what about, let's come back again here in terms of the decrease and everything. Now, when in terms of the decrease, here the graph, it will either decrease or increase, just like the hyperbolic function. So in this case here, it's only increasing on both of them. It's only increasing on both of them. And what we see is that if we are to talk of the increase here, increasing, so it's increasing for which values? For x element of real numbers, or you can say negative x element of a negative infinity to positive infinity, because there is no restriction here. It's increasing from here up until positive infinity. That's what happens. So the gradient is not affected by anything here in this case. So it's going to increase. It's decreasing, it's decreasing from negative infinity to positive infinity. So whether it's increasing or decreasing, it's still going to be the same thing. Okay, let's just talk of something like, maybe if the graph was maybe let's say if the graph was this, like this. So let's say here is 1, -1. So if in this case here, the graph here, we are saying it's going to be decreasing. Again, it's decreasing x element of real numbers, or we can say x element of what call negative infinity to positive infinity. That's what we need to understand there. That's what happens because it's decreasing throughout. Okay, so always remember that in terms of increasing and decreasing does not matter. You just have the same thing. It's just more like your domain. You don't need to stress it because your graph is increasing or decreasing throughout. Now let's now talk of getting the equation, getting what you call exponential equation. How do you get it? Now, when you are given in a y-intercept and also what is it, a point, so where it's cutting. So in this case here, we are given the asymptote and the y-intercept, and also b you are given. So in this case, you know that your job here is to find a. So to answer this question here, we can see that what is given to us here, we are given a point. So we're given asymptote. So asymptote is y equal to -6, okay? Then a point is the y-intercept in this case here. Y-intercept is 0 and -4, okay? Then what else are we given? We are given also q. Q is given. Q is a y, is an asymptote. So Q in this case is -6. That's what we need to remember. So Q here is -6. So this thing here and this here is still the same thing. Okay, so Q is your asymptote. That's what you just need to remember. I'm just showing you how you pick your values here. Now, what else do we have here? We are also given B. B is equal to 2. So it means that we can substitute our values to find A. We can substitute everything here to find A. So here we need to look for A. Find A. That's what is not there. Otherwise, the rest we are given. Let's see what we do in this case here. So our Y in this case is -4. Okay, equal to, what about our A? We are looking for A. What about we have got a 2. What about our X is 0. And then we are saying what called -6, which is your Q. So in this case here, any number to the power of 0 is 1. So we bring in the 3 there. So A in this case here is going to be equals to -4 plus 6 is going to be equals to 2. So our A is equal to 2. So our function, our equation will be equals to A is 2. Okay, then we have got 2 to the power of X -6. That's how we write our equation. Now, let's look for another one here where we are given 2 points and an asymptote. So when you're given an asymptote, you are given Q. That's what you just need to remember there. So let's try to see what is given to us. What is given to us is what? Is a point. And in this case, a point is -3 and 19. Okay. What else is given? Asymptote. What that I would want to call it as Q. So Q is actually -8. Okay. So what about then we're also given origin. Origin. So let me just put it as a point there. So let's say points in the and let's say here 0 and 0. That's our origin because it's passing at the origin. Let's not forget that, guys. It's passing at the origin. So now when you come back now and you are now substituting in your equation, now you substitute everything. And what are you looking for in this case? You are looking for A because we don't have. We also need to look for B. So for the first one here, look for B. So let's look for B first. Now to look for B, how are we going to do it? We look for A first. Sorry, let me see here. Let's look for A first. Now, to look for A, we're going to substitute 0 and 0. So let's look at it and see. So 0 is equals to A, B to the power of 0 minus 8. So in this case here, our A is equal to 8. Our A is equal to 8. We take the 8 there. Our A is equal to 8. Now let's look for B. Now when you look for B now, we are substituting -3 and 19. Okay, -3 and 19. That's what we are replacing there. So what are we going to do now? We're going to take our original equation. Now we have got 8 as our A. So we have our A now. So we're going to say 19 is equal to our a is 8, then b to the power of what is our x is -3, then what is it, -8. Okay, so if we are to take that side 8, that side is going to be equal to 27. Okay, 27 is going to be equal to 8 over b to the power of 3, because we know that this is a negative, so it's an exponent. So we take the b3 there, 27 b3 is equal to 8. Then here b is equals to what is it, b3 is equals to 8 over 27. I'm just making this long, but b is equals to cube root of 8 over 27, which is equals to what is it, 2 over 3. So our b is 2 over 3. So in this case here, it means that we have everything that we want. So our equation will be y is equals to 8, which is our a. What about the b is 2 over 3 in bracket x -8. Okay, so that's what you guys need to understand when you're solving such kind of problems. Okay, so just know that we don't need to stress. Know that if you're given the origin and the point, you substitute the origin so that you can make everything. You make y and x 0, then you can find your a first. But otherwise, the q you always be given in this case, because you'll be given as what, as an asymptote. That's how you take it. Okay, you take it as an asymptote, and then you are good to go. Okay, so until next time, guys, don't forget to subscribe to our YouTube channel, and also follow us on YouTube, on Facebook, Instagram, and Twitter, and what is it, and TikTok. Okay, thank you so much.